Determine for the function h of x equals x squared minus 2x minus 8 over 3x squared plus 6x for x is less than negative 2, 1 for x equals negative 2, and the absolute value of x plus 2 over x plus 2 for x is greater than negative 2, at the x-coordinate of x equals negative 2, whether it is parts a through e. Each of the parts involves the continuity of the function. The first thing to do is write down the definition of what it means to be continuous, and that will be the limit as x approaches a from both sides of h of x equals h of a. For this problem, we're looking at the x-coordinate of x equals negative 2. So we can write it down specific to this problem. Limit as x approaches negative 2 from both sides of h of x equals h of negative 2. We don't know this is true yet. Let's put a question mark above it. But if it is true, that's the result needed to be continuous. The first thing to determine here is the limit as x approaches negative 2 from both sides of h of x. H of x here is a split expression function, and it's splitting right at the x-coordinate of negative 2. And that means to work out the two-sided limit, we have to work out the two one-sided limits separately. We have the limit as x approaches negative 2 from the left side, indicated by the negative superscript on negative 2. And the limit as x approaches negative 2 from the right side, indicated by the positive superscript on the negative 2 of h of x. Let's start with the left-sided limit. The left side of negative 2 means less than negative 2. If we look at the split expression function, less than negative 2 would have that expression. So we can now replace h of x with x squared minus 2x minus 8 over 3x squared plus 6x. The next thing to do is try plugging a negative 2 in for each of the x's. That will give us negative 2 squared minus 2 times a negative 2 minus 8 over 3 times negative 2 squared plus 6 times negative 2. Negative 2 squared is a positive 4. Negative 2 times a negative 2 is a positive 4. Then minus 8 over 3 times negative 2 squared is a 4. And then 6 times a negative 2 is a negative 12. 4 plus 4 is an 8 minus 8. 3 times 4 is a 12 minus 12. 8 minus 8 is a 0. 12 minus 12 is a 0. We have the 0 over 0 indeterminate form. We will have to rework this. Since these are power functions, we can try the factor and cancel method. So we'll have limit as x approaches negative 2 from the left side of the numerator is a trinomial quadratic. And so we can factor into x and x. We need two numbers that multiply to be negative 8 and add to be a negative 2. A negative 4 and a positive 2 will take care of that. The denominator is not a trinomial quadratic. It's missing the third term, the constant. But it does have a common factor of a 3 as well as an x. So we can factor a 3x out of there, which will leave us with an x plus 2. And it's the x plus 2 factor that's making the 0 in the numerator and denominator as x approaches negative 2, but they can cancel. We now have the limit as x approaches negative 2 from the left side of x minus 4 over 3x. We can now replace each of the x's with a negative 2. That'll give us a negative 2 minus 4 over 3 times a negative 2. Negative 2 minus 4 is a negative 6 over 3 times negative 2 is a negative 6. A negative 6 over negative 6 is a 1. Now we can work out the right-sided limit. The right side of negative 2 means greater than negative 2. And up here at the split expression function, for greater than negative 2, we will use that expression for h of x. So h of x can now be replaced with the absolute value of x plus 2 over x plus 2. The next thing to do is try plugging a negative 2 in for each of the x's. That'll give us the absolute value of negative 2 plus 2 all over negative 2 plus 2. Negative 2 plus 2 is a 0, so we'll have the absolute value of 0 over 0. Since we have a 0 inside of absolute value symbols, we will need to look a little bit closer which side we're approaching from. We have x approaching negative 2 from the right side. The right side of negative 2 means less negative than negative 2, like negative 1.99. And if we plug that in for x in the numerator in the absolute value, something less negative than negative 2, like negative 1.99, and add 2 to that, it's a positive number inside the absolute value symbols. The absolute value symbols will ensure that it remains positive by not changing it. So if we remove the absolute value symbols, we will have a positive outside of it. It's already positive. It stays positive. We have the 0 over 0 indeterminate form here. However, the x plus 2's can now cancel, leaving a positive 1 over a 1. And positive 1 over 1 is a 1. To determine the two-sided limit, we would compare the results of the one-sided limits. There they are. They're both a 1. So the two-sided limit up here is also a 1. The next thing we want to determine is h of negative 2. H of negative 2 is right at negative 2, so at the split expression function we look where x equals to negative 2, and that's here, and h of x is a 1 there, so h of negative 2 will be a 1. So we have the result that limit as x approaches negative 2 from both sides of h of x does equal h of 1. Or another way to write this is limit as x approaches negative 2 from the left side of h of x equals the limit as x approaches negative 2 from the right side of h of x equals h of 1. This result is situation A. It is continuous.